Hi, everyone, and welcome to the MLOps podcast. I'm your host, Dean, and today I have with me Almog Baku. Almog is a serial entrepreneur and technologist. He is a maintainer of Kubernetes, the tool every data scientist loves to fear, and Almog eats it for lunch. He's an expert and a consultant in the fields of cloud native, AI infrastructure, and foundational models, and he is the organizer of MLOps Tel Aviv and OpenAI and GenAI Israel, which are popular communities with more than 1,000 members. He's also the creator of the newly released Raptor ML, which is an open source framework to help you transform your Python code from notebook to scalable production. Hi, Almog. Thanks for joining.
Hi. Wow, you set the expectations so high. Like now I'm blushing.
Well, I'm really excited to have you here. We've been having these conversations offline, and this is a good excuse to let other people in on the finer details. You're going to get to know Almog. He has a lot of really interesting opinions and thoughts and experience in this world. But let's start with the beginning, right? What was the first machine learning model that you ever built?
Wow. I think this is a funny story. So it was like back at 2019, like early 2020, like everyone was at lockdown and I just closed my company and I was like, what's the big next thing? It's probably cyber, but it's probably also AI. So it probably should be like in the intersection of cyber and AI. It was totally bullshit. I just bullshitted my way. So I was like, all right, so if I want to build something, I better learn it. So I took the first AI course and I built this dog breed classifier, totally useless, but it helped me like understand, it's not that complicated. And then like you dive in and see it's very complicated, but I don't know. I guess like the only way to feel the big next thing is just to get your hands dirty. And today we have LLMs. Yeah, I just wasted my time building something nobody needs. But yeah.
Well, we're going to get to that in a moment. I guess the other thing that, at least to me, the first time I heard it was crazy, is how does one become a maintainer of Kubernetes?
So it's actually a funny story. So with my previous venture at Remoto, so we've built a system that enabled toll-free data, like things like toll-free calls, 1-800, but for data.
Sure.
So back in 2015, we didn't raise that much money, like even like today. And I'm not even talking about 2022. So we actually took this bet. We was like, all right, so we need to save with the cost of R&D and DevOps engineers, because what the heck is DevOps engineers? It was relatively new. So we just betted about this unknown technology. And so basically the way to become a maintainer is to solve bugs, because Kubernetes had a lot of bugs back then and somebody had to fix them. So me and the team joined and start contributing. So yeah, how did you end up with like all of the fascinating things you guys doing at DagsHub and DVC, and like I think you introduced an integration with PyCaret, right?
Yeah. We have a bunch of integrations, and unfortunately at this point I don't write enough code, even though I sometimes do a bit to preserve my sanity over the weekends. But I think originally what led us to build what we built is sort of a higher level understanding that it's strange that it doesn't already exist, and then sort of saying like, well, if no one built it already, maybe we should try, and maybe some confidence, maybe too much confidence and hubris that we believe that we could actually succeed. But then a few years later and a bunch of code lines later, we have a lot of really awesome integrations with a lot of really awesome tools that other people built, and we try to contribute wherever we can, but also a platform that's useful to a lot of people. I guess the bug way is really true, right? Like I think that one of the easiest ways for people to contribute to open source is when they try to use it and realize that something doesn't work, and then you get this escape hatch, as we like to call it, that you go one layer deeper and actually look at the code and contribute. that's a gateway drug for some people because then they become addicted to open source, which I'm totally for. But I guess specifically, do you think that the fear of Kubernetes in the data space is justified?
Yes, of course. like, like, if I'm a data scientist, like every other day you have a new paper released, you have a new LLM or foundation models that are basically terrifying me because I might lose my job. And now to add to that learning like Kubernetes and engineering and like what is this reconciliation loop and like manifest and deployment and like what? It's too complicated. How can you keep track?
Interesting. Maybe data scientists need to start writing papers about Kubernetes and ML, and then data scientists will learn. That might be an indirect way to do it.
So they will do a research how to understand how the model of Kubernetes works. Maybe this way, like
yeah, like do it. By the way, then like in the end, you'll have one line. You now know Kubernetes, and everyone will be like, I can't believe we learned it. But yeah, this is a cool story, and I definitely recommend solving bugs for things that you work with if you can. It's a really great way to get a deeper understanding of the tools that you work with. But now maybe taking a step back, right? Let's dive into the things that are actually interesting. So obviously, a lot of things have changed in the past. What is it now? A few months. Things are continuing to change. But I'm curious what your predictions are for ML and MLOps and where this world is headed.
So it doesn't heading anywhere, and I think that's one of the biggest problems. And you see many venture capitalists stop investing in MLOps, stop investing in traditional AI, which is a bit weird because all of these foundation models built on top of some foundations, which are this classic AI. But I think that the MLOps world took the wrong road. Like at some point, like MLOps started like as a fork of DevOps, but it never got merged. And it reached this point that the fork is so different than the main or the master branch that you can't merge it because it's just doing something different.
Sure.
But it doesn't work that way because the research team is like, it's so tiny, compared to the rest of the R&D team, compared to the rest of the engineering team. So it can't work that way. And to add to that, you have all of the foundation models that just reshuffling all of the cards. And like, what do I do? Like, I think that I just heard the other day a very weird story about a large enterprise that refactored their model, the recommendation system, to use OpenAI GPT-4 for recommendation system. Like,
interesting.
I don't even understand how like it's possible because
work.
Yeah, because theoretically it should be way cheaper using traditional ML methodologies like structured data, but I don't know, they got convinced that it's cheaper and better.
Okay, interesting. I guess the question is, so I mean there's two aspects of this, right? Which is, one is the connection between ML ops and DevOps, which I'm not sure. Like, you phrased it in as you said, a very blunt way. So I'm not sure which percentage of me agrees with what you're saying versus disagrees. I think that the problem that you asked about, like how we started with DagsHub, the problem that we recognize is that whatever you build for MLOps has to be communicative with the existing infrastructure in DevOps. Because if you build something that's totally disconnected, then things fall apart. But on the other hand, as you said, that the two things that we noticed that are meaningfully different are the scales that come with data and working with data. That's totally different from what DevOps traditionally handles, and the experimentation nature of machine learning, where you the analogy used is funny because this is how we think about it as well in software development. When you fork off from the main, it's because you're building a feature and that's going to be merged back into master. in data science or machine learning, you fork on off of main, you're doing an experiment, and some experiments fail and they never get merged back in, and that's fine. That's part of the flow. So so it's interesting. Sort of this analogy is, I like thinking about it that way, and I think you put that well. And then there's this other thing that you mentioned, which is like, what's the relationship between MLOps and what's now starting to be called LLM ops? I don't know how I feel about it, but we like inventing our terms, right? Like that's important. But there's this whole LLM thing, which is some things are kind of ridiculous, and a lot of it is because people have no idea what they're doing because it's so early, and that's fine. But yeah, I guess going to this second point, because I think like people have more well-defined thoughts on the first one. Like, how are you thinking about this sort of ChatGPT and generative models and things like that, and the role that data scientists have to play in that?
Okay, so you asked so many questions.
Sure.
No, I'll refer to something. So I think you said, it's well put. You said like, we build solutions that are communicating with the existing platforms and tools. And to add to that, I think that it's not only to the existing platforms and tools, we should build solutions that's communicating with existing processes and existing paradigms.
Sure.
And again, it's so funny to think about the foundation models and the LLMs because they're changing everything. But I think the important thing is that most of the organizations can't have a university, an internal university inside of them. Like, unless you're Google, you can just do research for the sake of research. You need to report to some investor. You need to provide some ROI of your work, and you need to provide some results. So you need to build something useful. And this is especially true when you are building production and operational use cases. So I'm not talking at all about analytical use cases, about reports. That's not my field. And to be honest, I don't find it personally very interesting. So I'm like, most of the thing I'm probably going to say is about operational use cases.
Sure.
And there, like, we see more and more companies shifting gears towards the applied data scientist mode.
Yeah, that's so. I guess how do you define applied data science?
Yeah, so like applied data scientists, they are basically data scientists, but they are aiming to build production grade models. And I want to be very clear about it because I heard so many definitions. I'm not talking about data scientists that's researching a real example from the real world. No, I'm talking about data scientists that researching around a real example from the real world, but they also going to deploy it to production and to make sure that they building the model. It doesn't have to be they writing all of the code, but they should have the notion for it. And it's like a huge state of mind, right? Because when you're building something for production, you need to remember, hey, this is what I have in production. This is what I don't have. This is the kind of data is existing in my data warehouse. Maybe because it's in the data warehouse, that's not really existing in production, and we need to build it in production. So if it's like a very complicated calculation, like, I don't know, amount of clicks over the last hour, like rolling window, and this kind of data is existing in the data warehouse, but not existing in your raw data, in your data lake, then it's going to be a nightmare to productionize it. So you need to think about this kind of information ahead. Like, when you start researching, when you open your notebook, you need to understand what you have and what you don't have. Right?
Yeah.
You need to write clean code. If you know that you have like a potential injection in your code, like, if you know it, don't protect from it, right? Most of the time we don't have cases like that, but especially now with LLMs and such, like, it's very easy to inject some piece of code or something like that, because systems becoming very complicated. Maybe you want to extract and gather some data from LLM, and to take that to a linear regression model and like doing fancy stuff. So when you think about the production in your mind, and you always remember that, hey, this is not just a research, it's someday it's somebody going to deploy it, then you write a very different program. Does that make sense?
Yeah, totally. I have a talk that's called ML in production. What does production even mean? And one of the starting slides is I show an image of a forest, and I asked if you build an amazing machine learning model and no one ever uses it, does it matter? And sometimes people raise their hands, especially like in academic environments, because I give this talk also at universities, and they say, well, if I published a paper, then maybe it does matter, even if no one ever uses it. But my sort of longer term response is that, sure, you could publish papers and that's important, but at the end, the goal that you have is for this to affect the real world. And that's usually if the work that you're doing remains in research, you never affect anything outside of your whatever archive, then it probably doesn't make an impact on the world, and that's a shame. So if you don't think about all of the things that you mentioned, which are great sort of concepts to think about, then you're going to do a lot of work. And if you're doing this work, you're probably a really smart person, and then it's not going to have any impact on the real world, and that's a shame. So I definitely agree with that. And I guess,
what are the responses for that?
Oh no, I think most people agree with that. Like most people are just not thinking about that because the work that they're doing is very, as an engineer, you sometimes build for the sake of building, and you don't think about the broader context of like what's going to happen with my product. And in general, I think that it's healthy to have some degree of product thinking, right? Like it's not everyone should be product managers, but it doesn't matter what your role is. If you're a marketer, if you're a salesperson, or if you're a data scientist, thinking about things in the context of this is something that needs to be wrapped in some package where someone can actually use it leads you to a lot of counterintuitive conclusions that you don't think about if you're just thinking about it like I'm doing something for the sake of doing it, which is also fine. But that's to me sounds more like a hobby than a job, right? So if this is sort of my take on that. I guess that I don't really know how this changes with ChatGPT, LLMs, and things like that. So how do you think like the job of applied scientists is going to look now?
So I think that's basically where things got interesting, because the foundation models, they are reducing dramatically the barrier to entry. So the very basic essence of data scientists and commoditizing the AI for everyone just changes, right?
Mm-hmm.
Because every kid today can write a very, I don't know if useful, but something that works, right?
Yeah.
So you have more data scientists that found themselves, hey, I can do just research, and I need to build something that goes to production, and more organization actually adopting this applied data science approach or paradigm, and you have more and more engineers that can actually help these data scientists and take things to production. And on top of that, now, because you have the foundation models, you don't need to use these very expensive data scientists to build everything. You can ask your engineer to do that. So eventually, I believe that these 2-3 roles, I don't know how to split it, they will consolidate into this new role of ML engineer or AI engineer or whatever you want to call it, which is some kind of a scientist that understand like models, understand some level of engineering, not backend engineer. He wants to need to know like how Kafka work and scaling and all of this kind of stuff, but he will have to understand, or she will have to understand, how to connect the dots from the AI world, right? How to compose a prompt that yields some relevant value that you can use with another really linear regression model, and how to do some experiments, because you need to see even like that your prompts do its works. Like if you're improving your prompt, you'll get 10x better results.
Yeah.
And in order to improve your prompt, you need to do research. So
Sure.
basically constructing some tables in pandas and constructing some questions and feed it to the model, maybe do some fine tuning. So we will have consolidation within these three walls of the new AI, the old AI, and engineering. At least that's what I see.
Yeah. No, that's interesting, and there's some sort of intuitiveness to it. I think that one of the things that's specifically unclear to me in applying engineering here is it seems that a lot of the work that's being done around LLMs has reduced the scope from quantitative to qualitative. So in the world of classical machine learning, when you would train your dog breed detector, that you and I also did this. I remember the Fast AI course. So you train your dog breed detector. You could have a test set that has like 2,000 images, and then run your model on those 2,000 images and get an actual score that shows you how good your model is, right? But with prompt engineering, or however you want to call it, you see companies where they're doing like 2 prompts, checking them out, and then saying like, well, this looks good enough. Well, we might as well try deploying this into production. So I think that sort of introducing the engineering aspects and the scientific aspects to everything that's AI, the new AI is really, really hard. I'm not sure how that's going to look. I'm curious if you have any thoughts on this, if that makes sense to you.
So think about it like building an e-commerce with React and microservices, building versus building an e-commerce website using WordPress. All right, you have like this access of professional and high quality results and good enough. And
Sure.
you can compare that to the access between ML engineers and data scientists. So if you want something like very high quality, very cheap, like you want to improve your business economics, you'll have to invest more money having a data scientist that can have this kind of models to use them to create data and to train your own model, or doing some fancy stuff like that, maybe developing your own model from scratch. I don't know. If you want to build something like MVP style, you're probably only gonna use like SaaS models and things like that, which are like at scale, they becoming very expensive. And if you want to be like in between, so you know how to collaborate between these two roles, or how to allow data scientists or ML engineers having higher quality solutions without learning each other's job, right? So
Sure.
think about it this way: if a data scientist, applied data scientist, would have the tools to build a model that he can on his own will be able to deploy to production, it will be way better. Of course, if you take the engineer to take this model, it will be way more optimized. So there is a trade-off here. You need to choose what's better for your organization or for your scenario. Does that make sense?
Yeah, it makes sense. I'm trying to think if like the aspect of like where LLMs enter the picture here to me is the consistency, right? Because so everything you said I agree with. I think that in the end there's a variance to the skill levels and the outputs that you get, and you need to decide how much money, time, whatever resources you're going to invest, and then according to that investment you'll fall somewhere else on the spectrum. I feel like sort of consistency with LLMs is interesting here, because if you're using ChatGPT and you type in something, it might do it. Usually it's not going to be consistent. And I don't mean consistent in the sense of like reducing the temperature to 0 and getting the same result every time. I mean consistent in the sense that slight rephrasing of the question can yield very different results. And the extreme case that everyone is now talking about is you can have 2 questions and have one word phrased differently, and then one response could be normal and the other could be offensive, right? So if you're Pepsi and you're looking to deploy this model to production in some context, I don't know, I just I didn't think this through. I don't know what use case. I'm sure Pepsi is trying to think of use cases to use ChatGPT. But if you're trying to do this, you want to make sure that it's not saying offensive stuff, right? So I think that's going to be a huge engineering challenge, and I have no idea how people are planning on solving that. But that's something that I'm very interested in.
So I think that's an ongoing discovery of the market. Like there are no right or wrong answers, right? Like mostly wrong answers right now.
Yes,
because like it's so funny. Like this group of scientists, crazy scientists, built something so huge that nobody understands how it works. So we do understand the mechanics of transformers, but we don't really understand how to optimize them. And every other day you hear about new strategy, how to attack it. So like, like we can talk about like, have you heard about roles or chain of thoughts?
I'm familiar with chain of thought. What was the first one?
So roles. So basically, this is so funny. Like a group of scientists created this research that discovered. So they discovered that if you basically explain someone how to think, he will be a better thinker. But obviously, so they discovered that you can apply that for LLMs. So if you explain the model how to think about some question, he will be better answering it. So for example, you have the chain of thought that you can ask the model, hey, what is 3 plus 2 multiplied by 4? And it will give you the wrong answer. But if you say, hey, this is the example, and the answer is, I need to multiply 2 by 4, which is 8, and then I'm adding it 3, then you'll get the right answer, and then we can instruct the model how to give us further answers. And another mechanism or like technique is roles. Like if you give the model the right context of the conversation, you are a mathematician with 10 years of experience and this and this. The model will be more in the context and in the state of mind, so-called, of the mathematician, and it will give you like more terminology from the maths world and etc. On top of that, like you have agents in Miracle or React. React is like reason and acting. Like so you can tell a model, oh, all right, so I want you to choose from this kind of options how to answer me. But it's not only that you answer me this way, you need to explain me why this is what you chose. So we just see like last month, AutoGPT was released, which utilizing this kind of techniques, and it just changed everything. Like people just went crazy. Wow, it changed everything, but it actually didn't change anything. It has commoditized the knowledge. And this is where things becoming interesting, because now every kid can play with this kind of technologies and understand how to yield way better results from the model.
Yeah, I agree. I think that's interesting. Like, to me, all of those discoveries stem from the fact that we, as you said, like we don't really understand how these models work. We understand it mechanically, but we don't really understand how the magic happens. And so these discoveries are like, I don't know, like you look at a kid and it's I don't know, it sees its own shadow and it realizes that the shadow comes from it and things like that. So there's like emergent behavior that's coming out of this thing that we didn't know in advance, and that's leading us to more interesting applications. I guess I'm curious to hear your thoughts about like the role data has to play here. So as I mentioned earlier, it has a very clear role in classical ML. I think it also has a very important role, like maybe I'm cheating, I'm telling you what I think before. I think it has a very important role to play in LLMs, but I'm curious how you think about it.
Yeah. So there is this like famous paradigm, maybe like famous idiom in classical or like the old-fashioned AI world, which is garbage in, garbage out. I think it couldn't be more accurate in the world of LLMs, because if you basically ask very silly questions, it will give you very bad answers. So, like if you need to train the model with very high quality data, and many researchers and practitioners are debating that this is basically what like moves the needle for OpenAI, because they had very high quality data to train on. And you also need to ask really good questions. Like if I'm gonna ask a very vague question, like summarize this content, it will give me like a good summary. But if I'm gonna give the prompt and very accurate instructions, like I want you to give me a friendly summary for 8th grade readers, and etc., it will be way more accurate. And to add to that is, what are you summarizing, right? So if you want to create a summary based on your operational data, how do you construct the data from the operational systems, transform them to native language, and then how do you create the questions and the answers about this content? And how do you make sure that, again, you didn't pull some information from the data warehouse that won't be available on the operational mode? And because it's so easy, most of the engineers right now going with the intuitive approach, which is like building transactional requests, like online real-time requests to OpenAI to do some inference. But if you don't have the data, like what do you do? So it's even more important to have quality and accurate and existing data.
Yeah, I agree. I think that the way I phrase this to someone is that when you can't build the model, then the data becomes more important. And because in the world of LLMs, fewer people are going to build models. If you're listening to this and you only now are coming to this conclusion, I'm sorry to be the messenger of bad news. But that means that the data becomes more critical, because that's what's going to determine the result that you get, as you alluded to earlier with the garbage in, garbage out. And so being able to select the right data and then sort of connect it to the model that you're going to fine tune, or adding or using the data to add logic before and after you prompt the model is going to be very, very, very meaningful in the results that you're getting. And with respect to our conversation earlier, like the product that you're going to get in the end, because most of the people that are using OpenAI or any other large language model provider are trying to build a product on top of that. AutoGPT is just one of those examples, right? So yeah, I think that's really, really important.
So I think you said something really interesting. You said like you are building a product, and it's really helps to think about your product as your data. So what we're doing is we as data scientists or ML engineers or architects or whatever, we just wrangling with data. We're just shifting it, slicing it, dicing it. We're doing some magic with the data, and then we feed it to some huge mathematical algorithm, whether we understand it or whether we don't, and we're getting some results. So when we do that, we need to be very thoughtful about what we control, which is the data, because this is probably the most deterministic piece of information we have.
Yeah, I agree. I guess continuing sort of this line of thought of a product, how are you thinking? And as you said earlier, it's early. I'm sure people won't hold you to your words too strongly, but how are you thinking about productionization of LLMs? Like, some companies, a lot of the people that are listening here are listening because they are either having challenges or they're not having challenges, but they're trying to learn from other people about getting machine learning into the real world. How are you thinking about LLMs and getting them into the real world, and maybe how that compares to the older models that we've done this with.
So just for the sake of the conversation, I guess we are talking about hosted LLMs, right? We are not talking about the SaaS solutions like OpenAI or Azure OpenAI and etc. We are talking about Llama and like stable LM and like the open source models.
You can answer whichever one you prefer. Both. I'm open to it.
I think it's gonna be the same because
the same as the old world, or the same between the hosted and the non-hosted.
So no, between the hosted and so it's gonna be the same for both of them. I'll explain. So when you think about hosted LLMs, they are basically like any other SaaS API. So you just send some RPC, you send some request, you get some response, that's it. You don't care about the deployment of the model itself. When you think about the hosted LLM, it's just like deploying any other model, which is like deploying any other piece of technology. You have some complicated sets of requirements and you need to fulfill them. Fortunately, the most complicated problems about LLMs are that they are very huge. They weigh a lot of gigabytes or terabytes. So it takes a while to load them. And they utilizing a lot of memory. So this is very challenging. That being said, the same problems, we had the same problems like last year and 2 years ago. We still had big models, and there are great solutions out there in the market for large models. So how is that different? Because we call them LLMs. It's yet another neural network, right?
Fair enough. I mean, to be honest, I think that there is a question of like whether or not the size, there's a threshold that presents new limitations, which I'm still thinking about. I don't have any like strong conclusions here.
Usually the challenge with large models are like loading them because it's very costly. So if you have a lot of data, like a lot of requests, queries per second, then it makes a lot of sense. You are starting a large machine, you're serving the data non-stop, so you're utilizing this very expensive machine all the time. The challenge is starting when you're trying to scale, right? So sometimes you might find yourself in a position that you have a very expensive machine that it took you a few minutes to heat up and to warm it up to load this model, but nobody utilizing it. So how do you balance it? How do you balance it to provide like the perfect combination of expense, quality of service, and I don't know, like latency? But there are tools for that. It's not cheap. It's expensive. But there are solutions for that because the exact same problem occurred, I don't know, last year when people tried to deploy stable diffusion models. So it's way more expensive. It's way more expensive. There is a lot of room for improvement, but it's still the same problem. Did that make sense?
Sure. I mean, one of the people that I spoke with last week, I was in Boston for conference, was talking about a case where they had to split the model inference across multiple systems because the model was too large for a single GPU. And so I think there are some challenges that are like very extreme scale that you don't get often with, like, there were old models that were huge. Like even before we got to LLM lands, like by definition, there were just really big models and things like that. I think that it might be possible that we see a lot more of that. And those are things that if you're a startup, if you're a small company that wants to use it, it's going to be pretty difficult to handle. I think that in those cases, companies will start by using the SaaS solutions and introducing their own self-hosted versions later. But I think there are some things that I find interesting. I'm not sure if anyone has like a good out of the box solution.
Yeah, it's quite interesting. I'm not sure I have the answer, but from what we know right now, like if you look at the large llama model, it can fit with very expensive but regular EC2 instance. Like
Sure.
it's not like the cheaper instances. It's more expensive if you want to get good quality, but it's something that you can use like an existing technology to serve it upon. So maybe in the future we will have more and more massively huge models. I think that's the beauty of it, that we don't know, and every other day a new model is released. It's so fun and exciting, like it's crazy.
That's true, but we can't go to massive language models because then the acronym would be MLMs, and that's multi-level marketing scams. So we need to find a different name. But
a different technology to reduce or because it's gonna be very expensive.
Yeah, that's true. I mean, there's this talk by Sam Altman that's making the rounds now that OpenAI is not planning on increasing the size for their next model, but actually like finding ways to get better performance out of the same or smaller sizes. So maybe this is like the upper limit. I don't know. Like if you take the human brain analogy, then we have a few orders of magnitude to increase before we get to AGI. But maybe that's a different discussion. I guess I wanted to ask about Raptor ML, right? So this is something that you've been working on for a while now, and now it's out in the open. Correct me if I'm wrong, but people could just go ahead and use it. So can you explain what it is and why you created it?
Yeah. So if you remember the process we've talked about, where data scientists stopping being data scientists and starting to be applied data scientists, which is exactly the same with a different state of mind, Raptor tapping exactly in this process. So it's a project I'm doing on my spare time. It's not commercial. And I believe, and a lot of practitioners that helped me along the road believe, that the only way to solve the productization problem is changing the state of mind. And it should be for every practitioner in the organization, as well as for the organization itself. And we see more and more large corporates that adopting it, whether it's Microsoft, Google, LinkedIn, etc. And after you basically solve your problem using this new state of mind, then Raptor just tap into this process and help. So basically what it do, it lets you write your feature engineering process and modeling process with your favorite IDE or notebook. Then you can export it to Kubernetes. And after you export it into Kubernetes, the Raptor backend side are connecting to the real-time data sources, to your historical data sources, scaling your system, improving your quality of service, and doing all of the Mojo Jojo engineering side, while your model gets deployed to SageMaker. So basically, there is no magic here, because the real magic is changing the gears while you are developing your model. But if you did that, then Raptor just do all of the iterative and engineering overhead, because these are some stuff we can generalize and do that for you.
That's awesome. I actually like that approach, where you're basically saying the tool assumes a certain state of mind or assumes a certain workflow. And if you take on that workflow and state of mind, then it's going to be really valuable. Like that's a sort of a very clear prerequisite that will make sense or won't make sense for people. But I think I like the coupling, basically, is what I'm saying. And I'm guessing that you're also bringing a lot of your experience in these other areas that we spoke about in the past to make it work well. But I like the idea of like, here is how you should work, And if you do, here's something that will make that workflow much easier and more powerful and better.
Yeah.
I guess because this is sort of a question that a lot of people ask when they look at and this is open source again, so you can go ahead and use it to the audience. But because something that people might ask, there are other tools that help you deploy or containerize the models and things like that. How is Raptor ML different than those solutions? So I don't know. The ones that come up to my mind would be like Bento or Selden, things like that. And then of course there's the cloud provider solutions. But let's say those are also maybe a good comparable.
So Raptor uses Bento behind the scene.
Oh, nice. Okay.
So Raptor basically, like behind the scene, it's a huge computation engine for production. Mm-hmm. So with Raptor, maybe I'll walk you through the process. So let's say I want to build a fraud detection model and I have these, 5 features. One of them is I want to take the IP and translate it to your country using geocode. Right? Yeah. Mm-hmm. So
sure.
I need to write every feature as a function. I'm getting as my input for my function the data as it is. Mm-hmm. And then I'm in a transactional manner, I'm writing how to transform the row into a column. Or I can add some decorators to instruct Raptor to do some aggregations. So I don't want to get one row, I want to get a few rows based on this rolling window, and I want from these rows to get this field, and on top of that to do this aggregation. Mm-hmm. After I'm done constructing my features, I can say, hey, so I want to take this feature, and this feature, even if this feature C is built on top of X and Y, and Raptor know how to build on top of that the DAG to build the data, and it gives me like a data set ready for training based on my regular data for training, like my CSV or Parquet file. After I got my data set as a pandas data set, I can train my model. And when I'm done, again, I'm wrapping it with some decorator, and then I can say, hey, Raptor, export it. So behind the scene, Raptor translate all of my Python functions into some Kubernetes manifest that can then be later translated to production code with Go. And it can take my model and containerize it using Bento. And using the power of Bento to deploy it to SageMaker or whatever. So the real magic here is how to make things make sense for data scientists and to process the data in production, because the data is the problematic part. The data is the product.
I like that a lot. Yes. So for the audience, this is the first time Almog shared with me like this presentation. So all my reactions were genuine, like my eyebrows going up. I'm going to repeat what you said and to make sure that I understood it. And also maybe this would be useful for the audience. But my answer to the question that I just asked you, according to what you just said, is that the other tools that I mentioned are very focused on just deploying the model, whereas Raptor is thinking about this as an end-to-end system that needs to be deployed. And so you're not just looking at the model, which is important, but just one of the pieces that you need to work with, but actually taking it back all the way to the raw data and getting me to the point where I have something that's usable, which I love. I have another talk that I give where I say like a model is just another data transformation step. And so it seems like what you're doing with Raptor is sort of embodying that into a system that gets you to production based on Kubernetes, which is great because it means it's sort of inherently more scalable. So that's awesome. I really like that. And again, this is the first time I'm hearing the pitch for it. So this is really my genuine reaction. This is awesome. I don't know, is there,
just
is there anything else? Awesome. Yeah. So we'll add the link to the description of this episode. I guess, is there anything else before I ask you the last two Spitfire questions But is there anything else you'd like to add about Raptor ML that people should know about it, or how to use it, or something like that?
Yeah. A lot of people, when they try Raptor or looking at the README, trying to ask me, like, what's the magic? Like, you're doing a lot of module Jojo stuff, like how it works. I'm not doing any magic. It's like the data scientist shifting the gears toward production. That's the only requirement and the enablement of this solution. Without that, don't even bother. It's if you are not adopting the applied data science approach, this is not a tool for you, because you can use Raptor and use pandas inside of your feature definition. It won't work because you need to adopt this stateless and stateful state of mind, the transactional approach. So it's require a paradigm shift, but if you're adopting it, and if you want to be an applied data scientist, it's going to be worth it.
Love that. So you heard it here first. If you're a data scientist that wants to become more applied data scientist, get closer to production, think about data as a product, and you're looking for a tool that will help you do that, go through that shift, it's open source. Go ahead and use Raptor ML. I'm definitely going to try it and give you some feedback afterwards. So before we wrap it up, tell me something or a few things that are true, but few people would agree with in the world of ML, MLOps, LLM ops.
Wow. Okay. A few things that's true, but most of the people won't agree. I think that the MLOps is dead. Like, I think that only 50% agree with me. And I hope that the 50% that are not agreeing with me gonna be very successful in the MLOps world, because it's very challenging today. But it's not gonna be like dead. It's gonna be dead like Phoenix. So I believe that we will see the MLOps and the AI tooling world evolve into something way more commoditized. We're gonna see a lot companies adopting the product-led growth approach and allowing you to just click to register and to download. And most of the closed source companies or like top-down solutions gonna die, because in the world of the availability and the democratization of LLM, it must be easy and it must be reachable for users. So yeah,
fair enough. And so to wrap it up, any recommendations you'd like to give to the audience, aside from Raptor ML, which, as I mentioned, I'll add in the description, but it doesn't have to be data science related. You can recommend books, Netflix shows, whatever you want to.
Foundation, but not the foundation models. Like, I meant the Apple TV show. It's actually a pretty good one. If you are not familiar with it, it's written by Isaac Asimov, which is one of the most famous sci-fi readers of all time. So take that with the budget from Apple, and the production is amazing. The story is well written. Just watch it. If you're a true geek or if you're a fake geek, you're gonna love it. Or love it. I love it. Really good.
Amazing. Any other recommendations?
Yeah, I recommended too much stuff. Yeah, I have a really good one. Don't believe me. Just try things, research, experiment with Raptor, with other solutions, with this new state of mind approach, with Miracle or with React prompts. Just experiment with stuff. Get your hands dirty. I believe that's the best way to learn.
I love that. I totally agree. It's easier to... it's not easier. It wasn't always easier, but today it's easier to try than to just accept sort of common wisdom. So just go ahead and try. Maybe you'll find out the next AutoGPT. Who knows? I guess from my side, I'll give one recommendation. I just finished reading a trilogy of books by Adrian Tchaikovsky. The trilogy is called The Final Architecture. The first book is called Shards of Earth. It is a lot of fun. It's a proper space opera, which I haven't read in a while. So I totally recommend it. and there's like a decent ending, so it's not left open in an annoying way. So you should totally read that. Aside from that, I just came back from ODSC in Boston, which was great. I gave a talk there. I think the talks are going to be public later, so I'll share a link with that. But also, I had the talk a few weeks ago in Data Council Austin, which is now public. So I'm actually talking about somewhat related topic, which is machine learning in production. What does production even mean? So a lot of the ideas I shared here, I talk about them there. So if you're interested in that, go check it out. But to finish off, I think the most interesting recommendation we have from this episode is to try out Raptor ML and to tell Almog what you think. He's looking for feedback and everything. So I'm sure that would be awesome. And if it helps you, that would be the most awesome. So with that, Almog, thank you for joining. This was a pleasure. It's always fun talking with you, and now everyone gets to listen in. And I'll see you next time.
Thank you for having me. Bye-bye.
Bye.
Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.